Hello guys, welcome to Hard Coder. Today we are going to see the Lead Code Daily Challenge for the day 17th October 2022. Let's dive into the question. Lead Code 1832. Check if the sentence is Pangram. The problem statement is a pangram is a sentence where every letter of the English alphabet appears at least once. So, given a string sentence containing only lowercase English letters, this is the main point to be noted, and return true if sentence is pangram or not. So we'll be given a sentence and we need to find if the sentence contains every lowercase English letters or not, which will be the condition for pangram. So let's dive into the approach. Here we'll be discussing three approaches for this problem. So the first approach is we need to find if every lowercase letters from A to Z appears in the given sentence or not. So firstly we'll need to check for A. So we'll iterate one by one. So we'll be running a loop and checking for every character and so on. When we find A, we have found out A. So we'll continue to next character, that is B. So we'll again iterate over the given characters in the string, and if we found the required character, we'll again just go and search for the next character. So next we'll go and search for C. So again we'll search for C. We have found out C. So we'll continue with other character D. So we'll run the loop and check if the D occurs or not. So D is occurring here, so we'll check for E. So we'll check again and again till every characters are present in the given string. If so, we'll return true or else false. This is the first approach. And in the second approach, we are going to use a set, and we'll iterate over the firstly we'll create a set and we'll iterate over the characters of the given sentence, and we'll continually adding the characters to the set. So firstly we'll add T, then H, then E, Q. Every characters will be added. The set has special condition that only one instance of a particular character will be present. So set will take care of the duplicates. So finally the set size should be 26, which is the total number of lowercase English alphabets present in the English language. So we'll add up every character to the set, and finally we'll check if the size of the set is 26 or not. If it is 26, we'll return true or else we'll return false. This is the criteria when we use the set. And thirdly, we'll be using I'll write it up. So this is set and this is loop. And third approach is using arrays. So firstly we'll create an array of size 26. So it will be 0, 1, 2, etc. up to Z, that is 25. So initially when we create the array, every cell will be having integer value of 0. So the ASCII character of we need to remember the ASCII character of A, that is the ASCII character of A is 97 and B is 98, and it goes on up to Z, which is 122. So we can see that if we subtract 97, it will be 0. So we can represent this 0 for A, and when we subtract 97, we get 1. So we can represent B in first index, and it goes on up to Z, that is that will be having the value as 25 when you subtract 97 from it. So that will be 25. So what we are going to do is we'll iterate over each character and we'll take the character, that is if we are iterating I over array, I mean the given string, if we are having the index as I, so we'll take the character present at that index, so str of I, and we'll update the arrays value at ch minus the given character minus 97 in order to get this is we are doing this in order to get the index position of the array. We'll update it to 1. So this is the approach. So let's dive into the coding section. So we'll discuss the first approach. Firstly, we'll take the given character, this. What we are doing here, guys, we are just taking the index, that is 0 from 0 to 26, and adding it to 97 so that we'll get the corresponding character. We are typecasting it into character, so we'll get the corresponding character. So we'll iterate over the complete sentence. So we have given index as I in the outer loop, so we'll use j. We'll keep a flag pointer, flag variable, so initially we'll have it as false. If we reach the required ch character, we'll change the flag variable to true and break from the loop. So if the character is not found, that is, will return false, else we'll continue. Finally, we'll return true, that is, every character are present in every lowercase English characters are present in the given sentence. Let's try it up. Yeah, it's working fine. So let's walk to the second approach. The time complexity for this first approach is order of n, because we are iterating over each character 26 times. That is 26 into n, that will be rounded off to n. And space complexity is order of 1. So that's it, guys, about the first approach. And in the second approach, we'll be having a set of characters. We'll consider this as scene. We'll iterate over the sentence, keep on adding it into set. And finally, we'll return if scene dot size equal to 26. This will be returning true if the size is 26, or else it will be returning false. So let's try it out. It's working. It's working fine. So time complexity is times of n. We iterated only one. It is better that compared to first approach. And space is of 1, because we are using only the maximum size of the set will be 26. So we can consider this as a constant. So it will be constant time space complexity. Then we'll move on to approach number 3. So we'll comment this up. We initially create an array of 26 characters and we'll iterate over each characters. And we'll update the index of corresponding characters representation. So firstly we'll find out the index which will be representing the current character. So in will be sentence current character minus 97. So we'll update the in, so we can change this int array to boolean array. Why we are doing this? Because it will be taking up integer will be taking up 4 bytes, boolean will be taking only 2 bytes. So we are going with boolean array. So we can correspondingly have a count of characters visited. So initially the count will be 0, and if the character is visited for the first time, we will increment the count to by 1, and finally we will return count equal to 26. This will be helping in finding whether the given thing contains every character or not. So sorry. Array. Oh, sorry. That's working fine. The time complexity for this approach is U of n, and space is U of 1. It is constant because we are using a 26 array of length 26. Thanks for viewing this video. Have a great time.